If you want, you are using this one, then it's this. So you only have one term. And when you have one term, this is how you write the solution. The solution then can be written A, because lambda 1 is equal to lambda 2, so it becomes A plus B T, or A T plus B is the same thing. Don't say, oh, last time you put the T here, now you're putting it on the B. It's the same thing. Okay? It means one of the terms has a T, the other does not have. E to the power what? Minus zeta omega n T. Or if you want, minus C over 2m T. Now, when you look at this term, this is simply a constant. This is a straight line. This is now our decaying curve. So the overall becomes what? Another decaying curve. Are we together? Which means, again, it looks like this because of the minus. It doesn't go there, but it comes here. So, the critically damped one is lower than the overdamped, because this is a specific point. But the moment you change your C and you make your C bigger and bigger and bigger and bigger, it's overdamped more and more and more and more. You are playing around over that side. Which means this is the last point at which vibration is just about to happen. Are we together? So this thing is also not vibrating. It's exactly the same like that one. But it's the last point. So in principle, you have the critical point, then a whole lot of overdamped cases with an increase in what? In C. Are we together? When does vibration happen? Vibration happens when this C becomes less than that. Then vibration is going to occur. Are we all together?
Yes.
I'm trying to shorten it, not going into the actual things. Now we look at zeta less than 1. If zeta is less than 1, then it can't. Did we see that? It can't. Square root of is negative something. You can't find it. Are we together? So what can we do so that it can when it can't? We multiply inside by minus 1, which means we do this. Multiply the whole thing times minus 1. When we've done that, then it becomes what? 1 minus zeta squared. Now it's bigger than 1. Bigger than 0. And now we can find the square root of it. Now, minus 1. If we multiply by minus 1 inside, outside we must divide by minus 1 also. What we've done, we do outside and we keep everything the same. Actually, by minus 1 what? Squared.
No, square root.
Or square root of minus 1.
Yeah.
Now, in complex analysis, minus 1 is said to be equal to I squared. Okay? So simply we have multiplied inside by minus 1 and then outside by I, which means our expression becomes plus or minus omega n over I, square root of 1 minus zeta squared. So inside we can now find the square root, and then we have this. Now dividing by I, let's see. Let's multiply times I here. We have changed it, to keep it the same, we must put an I there. Because it was everything over I. So multiply by I, divide by I. And we have not changed anything. I by I is equal to minus 1 again. So minus 1 multiplied by plus becomes minus. Minus 1 times minus becomes plus. So this thing remains plus or minus. But it becomes plus or minus what? Are we together? Are we together? Right. Now, in maths, I won't take it far, I will just state and then we go on to our solution. To say, because of this, the solution will look like that. In maths, if you have y is equal to e to the power minus I theta. This is the same as saying e to the power I theta. This is cos theta minus I sine theta. So when you have e to the power I theta,